Good morning for ladies and gentlemen for this webinar session. Welcome to our webinar session with OpenLegacy and Anabatic. For today, we would like to discuss regarding automating API generation and DevOps pipeline for IBM AS400 system. Hopefully, after this webinar, you know what is the positioning of the solution itself, and will be helping you to provide more flexible system to moving forward in the digital transformation era. Today, I have myself representing Anabatic Technologies as a SVP for Solution Sales, and together with me, I have two expert practitioners from OpenLegacy. I have Martin here and I have Michael. Martin is a product marketing director for OpenLegacy, and Michael is a regional solution architect for OpenLegacy. For today, we would like to discuss regarding the digital transformation and IT landscape in Indonesia, just to give you some brief what is the digital transformation in Indonesia. And after that, we will discuss more detail how OpenLegacy can helping your company to moving forward to transform your legacy system more digital and helping you to moving forward reach your business goals. And Michael will present some demo to give you a few how the systems works. And after all the session, we will close with the question and answer. Just let us know during the session. You can ask directly to all panelists here, all speakers here, or you can put in the chat whatever you would like to ask for the expert on this API generation. Hopefully, we can cover all your concern during this webinar session. And if you need further discussion, just let us know. So for today, I would like to give you some brief regarding the IT landscape in Indonesia. Actually now, digital economies in Indonesia are moving to the digital transformation. All of the industry talking about the cloud transformation, big data analysis, and also social and mobility acceleration and innovation. With this situation, all the entity are pushing for transform from their legacy, the traditional application to more flexible to cover for the digital transformation itself. Based on IDC prediction for IT spend in Indonesia regarding the digital transformation itself, IT spends totals around 465 trillion for cover all the digital transformation in Indonesia. With this figure, we can see what is the spending for IT regarding the transformation itself. And I need to pointing out some part of this survey from IDC that now all the entity are moving to the digital innovation expansion, and they do some revolution in application development, but honestly said that we are facing the legacy system sometimes cannot cover full the transformation journey of the entity. That's why for if we can share with you the modernization of the legacy digitalization, I get some quote from the modernization of the sorry, I have some delay on my slide. So from the legislative modernization digital transformation, from Deloitte, they told that modernization can be achieved without code freeze because we understood that all the business are should be moving forward without any big impact to their operation. That's why the modernization, the objective is they expect without code freeze and all the improvement done in the legacy operation. In here, I have 6 points that we need to pointing out regarding the modernization of the legacy digitalization. Is related to the user access presentation, and one thing I need to figure out is regarding the logic and also the interface that we need to be transformed from the legacy to moving forward for the digital transformation. And after we fixing out all the logic and interface, including the database, one thing that we need to taking care as a enterprise organization is how we deploy for each enhancement or improvement in the platform to cover all the digital transformation in the bank or in the organization that you are working now. To give you some brief, how your legacy can adopt this digital transformation, I will pass to Marty to discuss more details. How's this open legacy, how's the beauty of the platform can helping you to automate the API generation to helping you to be transformed and be ready for the digital transformation. Marty, I pass to you for the next session, the next discussion that we can share with all the audience here.
Thank you very, very much, Regina, for good intro. So we're talking about how to automate API generation and DevOps pipeline, and we'll give some real life examples from some customers as well. When we think about the whole automation, you first want to always think, especially with something like IBM, why are you trying to access them? What are the goals here? Digital systems accessing business logic and data. And you really want to think about easy and consistent on-demand API creation with clean digital assets that people are used to working with in the digital age. Plus, you really want to discuss things like speed at design time, so you actually get things done quickly, but also at runtime. You want to think about making it fast so it's responsive, so someone clicks on something on their mobile phone, they get immediate response. Anything along those lines, you have to make sure actually works really well. So those are kind of the goals people think about for any type of legacy system access or any access in general. And today we're discussing IBM I access. We can also discuss mainframes another time, which we also support among other systems, but we're focusing on IBM I today. So what's the current situation when we think about this? Some people still have green screens. They have to go through different green screens. We have a lot of customers who do that. Some have old, outdated web applications where they have to go through multiple different screens of web applications. They can't keep updating them. And this generally leaves people frustrated, customers frustrated. Sometimes they leave for other vendors. Sometimes you can't do everything in the actual application. You have to go into a bank or go into an insurance company. And that's just not good, especially with COVID and things like that. People really don't want to have to go in, but also anytime with millennials and other people like that, they don't want to have to go in just to be able to handle something that should be all done online. So you can't expand into new channels because of that. But there are some things that are good about these types of systems. Generally, they work, they're reliable, and it's hard to move away from them. So another question people like to ask is why now? Well, there's always new regulations coming out. We see a lot of customers who actually can't meet the regs with their current systems for a variety of different reasons. We've had a few of those deals recently come up in the US for some new regulations they've been adding in, but it's everywhere worldwide. But also you have new channels to support. You really want to think about, it's not just mobile or web or things like that, but it's actually different channels, might be third-party partners, things like that. Sometimes you have a merger and acquisition and you want to bring multiple systems together. But generally for a lot of people, it's really about flexibility, having flexible systems you can work with, and usability, making sure the users, whether they're customers or internal users, that the system is really usable and it actually works well. So when we talk about challenges to expose that logic, we talk about some of the legacy things people are tired of. Sometimes they're tired of ESBs, and that could be an MQ, an IIB as part of that. It might be some kind of protocol converter, or keeping up with the different middleware versions as they build those. But the other things we want to talk about is what are the different types of entry points. I mentioned earlier screens. Sometimes it's custom applications that you bought or ones that you built yourself. Sometimes it's a database you need access to. It might be third-party applications that you buy. So all those types of things are the entry points you work with. And people want to minimize things like facades. Facades are things which usually work on the actual IBM I system to do data conversion, because now you're taking up more processing power on the system, and you also have to involve those legacy people who usually are scarce resources to get that done, and that's painful. And I already mentioned ESBs, the middleware transfer layers, because you get stuck in the different versions, you get stuck in their pipes and all the other parts. But what are some things you want to think about? Well, people say, well, the IBM I security works. So I don't want to lose that working security in what I'm doing, but I also want to add in some kind of digital security, because if I'm opening it up to the web, I need web security. If I'm opening it up to different types of systems, I need that type. So, but we mentioned DevOps, we part of this topic. So all the types of things I mentioned earlier are really exacerbated by DevOps usage, because now people are releasing all the time. Some people are releasing every day, hundreds of times a day for some companies. But even if you're not doing it that frequent, it still is painful. And you're always building and testing and going through these processes. And if it takes too long either to build, or if you have to run through a whole suite of tests, you wind up having problems. But generally, these concepts that we're talking about are useful for any process, because anytime you can build up your test, you can build faster, you can test faster, you can test on minimal pieces of your system and not have to retest the whole thing. It's still an advantage no matter what process you use. So the process for DevOps, it really is a spectrum of different things that you do, from command line to all the different parts you want to do. Sometimes you want to just do building faster. Sometimes you want to do testing faster. Sometimes about getting all the way to deployment faster. And that DevOps is all part of that same spectrum you work with, and you want to speed up any of those parts to make a better job. So we mentioned we'd be talking about some customers. One is iAlone Insurance, and iAlone had some issues at the time. They always felt like their IT was lagging behind in deals. And they wanted to bring that instead to leading. They wanted to be able to close the deal and already have IT caught up, because that was a problem for them. And they really want to enable business process on the website and launch mobile apps leveraging these applications. And they're using IBM I applications. So how do they do this? Well, they said, we want to go to DevOps because we want to be able to release fast and get everything done. That was part of their process. They decided was really important. And they really want to meet today's needs and head into tomorrow, was what they said to us. And they want to improve process and automation, just make everything automated and work really well. And the architecture and infrastructure improvements were critical. So they decided to test this out with OpenLegacy on a project where they were going to work, this insurance companies work with a bank and actually work with the bank's commercial customers and try to sign them up for insurance. In doing so, they actually were ready 2 months before they signed the contract, which was an amazing thought to them. Usually the IT work comes a couple months after, and they can't start signing them up till long after the contract's signed, which means they got revenue quicker. And it also means they saved on development resources because they weren't working on that while they're working on the next deals and the other things they need to do. They also shortened their policy entry from 4 months, they said, to like 5 minutes, because everything was automated through the process instead of having to get certain sign-offs and other things they could do. And in general, they're producing 100 APIs in 2 months to be able to get this done. This is an incredible type of work that they were saying they couldn't do before. But in some ways, what's even more amazing about their process is, look at this. This is a picture they gave us. And all these tools are all standard DevOps tools with OpenLegacy's IDE being part of it, which just connects to the IBM I system. So what they had to do was they had to just do use OpenLegacy, which connects directly to the IBM I system. And now they have microservices they can deploy directly into, in their case, IBM's cloud. You could choose any cloud you like, and directly into Kubernetes. So the whole idea here is take a normal process for DevOps and just be able to use IBM I right inside of it as part of that. So when we think about that, we're actually thinking about parsing legacy metadata and then actually going to automatic generation of what we call software development kits, which are these deployable assets which you can build into microservices, where you then can design the API either automatically or make some choices to design it, to do automatic test generation where you can actually build tests that just work, and then you just deploy. Following that whole process makes it a lot easier to do. So we talk about that. We talk about the first stage, which is really parsing. Parsing is important, but what are you parsing is the question. In our case, you're parsing RPC, which is remote procedure calls, from a code fetcher. That's actually the thing which does the work, is it actually fetches something. It could fetch COBOL code, XML code, RPG, SAP, and parse that so we understand it, so we can produce microservices and know how to call the IBM I system. But we also can parse directly data, and we can go directly to a database, and we can actually parse the information about the database, turn that into a procedure call, and make the call directly to the database. So whether you want data directly or you want to use the logic that's part of the IBM I applications to maybe go get data as needed are two different things. Or we can do screens, and using screens we do trail files. Those trail files actually are there, and then you have reusable screen scenarios. So overall, the basic idea here is we have a lot of different parsing options that all work the same way. And you're going to see this in a demo from Michael a little bit later. We discuss SDK generation, and you could call this a module, we sometimes call it, or call it an SDK. It deploys directly from the IBM I, and you can actually put it directly in to the microservice with the API contract. So now you get a self-contained consumable asset, easily consumable asset, which becomes something you can process. But it's more than just that. You actually get the ability to do data translation inside of here, where you could also connect in a mainframe and an IBM I system if you want inside the microservice. We can do orchestration between those elements, and we can do templates, and the templates are a really powerful thing because they allow you to, for instance, put your security protocols in to there and automate that process so you don't have to regenerate if you're using the same security protocol. But in general, we support things like HTTPS to call down to that system. And also we use Java as the language that we're generating, which is strong typed, and we support data masking. You can get data and just get the data types you're looking for and not get all the other data from the database, which actually makes it much safer. And we also support some web types of security, OAuth 2, OLAP, and LDAP. Which you can actually then use directly in it, or you can configure your own security, like I mentioned earlier, through the templates and through other methods. Next, we talk about define and generate the API. Now, we have the ability to automatically generate, and we can just map to different things, or you can pick what are your inputs, what are your outputs. Do you want to rename them? Do you want to do certain things and analyze that information and pick it? And whether you use an existing API and we just bring it in and then map to it, or whether we generate one ourselves and then you use that API is up to you. But in general, we do is we analyze the inputs, map them to the APIs you want to use, and allow you to actually do the mapping or automate that process for you. There are a few different options there. And then we talk about automatic test generation. It's very important to be able to test things. So because I mentioned Java earlier, JUnit is the most popular for Java. We generate that for you automatically. But we also generate some JSON-based testing frameworks, which give you default input and output parameters and don't require you to have to know Java in order to do some of the testing, because sometimes your testers don't know as much Java. And we also generate Swagger pages, which gives you an interface so you can input the data and actually test it and see that the API and the system is working as needed. The whole idea of this is to allow testing, unit, deployment, integration, and regression testing all working together inside these systems. So that's a big thing to think about as you do it. And then we really do simplify the deployment. And I can argue that in some ways it's not us simplifying the deployment, it's the fact that we build microservices and we give you the Docker bindings for those microservices. And so in general, microservices are really easy to deploy because you can put them in containers, which we do for you. You can then deploy them on-premise or in the cloud in different systems. You can also just put them in jar files and deploy them in other ways if you like. Because they're microservices, they're really easy to deploy. But it's also really fast. I didn't mention this earlier, but it's a direct connection to the legacy system instead of going through middleware. You can always apply Kafka or some other type of queuing mechanism if you want, but we actually give you fast access to the legacy to the microservice, and then you can apply that to connect out to the outside world if you want to queue. That's your choice. Some customers do it. Some customers take direct call in and make it work directly that way. So in general, the whole idea is from the legacy system, we use a fetcher to the IDE, which then we parse it. Then we can generate into a microservice and deploy into the on-prem system. And then the application or into the cloud. And then from there, the application usage is running between the system you've deployed, wherever you've deployed it, directly to the legacy system and have that communication there. We support all different sorts of legacy systems, but we're showing you IBM I here today. And that's what the demo from Michael is going to be about. One more customer is Citibank, Citibank Mexico, which is the Mexican part of Citibank. And for them, the business value they really wanted to do was they needed to meet some satisfaction requirements for customers and for some regulations too as well. But they wanted to develop some open banking standards. And their solution was that they really wanted to create some new business workflows, and they created those really fast, which then allowed them to build those customer applications really quickly. From a technical value perspective, the way we did this by simplifying deployment efforts and accelerating the development efforts. And a lot of this was done by reducing their dependency on their middleware. Not everyone does that. Some people want to use their middleware with what we do, and that works fine. And this allowed them, though, to produce 100 services with APIs in 1 quarter. And they've been working with us for a number of years and very happy, and it's enabled them to do that a lot. So in general with Citibank, we're talking about the core systems here connected to some Oracle stored procedures along with some functions which are the applications themselves directly to some of these metadata information inside the SDK. Those then get linked to the API that gets built. And then the API, we can then do the orchestration as part of that and build out the microservices they want. And in their case, they initially weren't deploying to OpenShift, and now they're in the process of deploying to OpenShift. That's their choice for their Kubernetes option. I mentioned the other company earlier, and they were actually using direct Kubernetes. OpenShift is another flavor of Kubernetes from IBM/Red Hat. And so we have the REST APIs as the public interface and the Swagger configuration there. So this allows us to automate the whole deployment process and make everything work. So we really made it much faster deployment time, and 30% they said better API performance because we didn't have to go to the middleware TIBCO they were using earlier. And they're really creating 6 new business flows every 2 weeks. Every sprint basically is a two-week sprint. And so, sorry about that. And now I'm going to hand it over to Michael for an actual demo to see what's going on.
Hello everyone. So I'm going to show a demo about a very quick demo about our integration to AS400. But before that, let me explain a bit of the topics, the concept of our integration, right? So this, as Marty I mentioned just now, right, in one of the slides, there are actually 3 standard ways for our solution to integrate to our AS400 application. It could be through the screen, it could be directly integrating to the legacy programs or legacy applications, and it could be through the databases, right? Of course, we do have other types of integration which are not listed here. It could be directly through TCP/IP or can be using data queues and so on in the AS400. But typically, these are the 3 common ways, right, for our solution to be able to integrate to the AS400 system directly. So you can see that on the right-hand side is our solution. And Marty has already mentioned that we have this module called the SDK, Software Development Kit. that allows that has a connector, right? A connector could be connector to the screen of the AS400, connector to actually be able to connect to the connect and execute a legacy program directly. It can be a connector to the DB2 database, right? Running on the AS400, and then on top of that, right, we will generate models, right? Models means the representation of the interface or data structure that's required to be able to integrate to the AS400 application, running on the AS400 application. And then after that, right, after we have created this SDK, then we will wrap around that with the API that will be exposed to the outside world or to another application, right? So that's how we do it, right? So there will be two parts, right? One's the SDK part, direct integration to the AS400 system or application, and then we wrap around that with the API so that those functionality from the AS400 system can be exposed as digital services or API, right? Whether they're within a microservice or as a normal API. So this is a demo that I'm going to show, right? So as I mentioned, there are two parts to our solution. One's the SDK part that allows us to connect to the AS400 application. Then the other part is the API, right, where we get the request from the users of another application, right? And then they will go all the way, right? The SDK will translate the request to AS400 connectivity to the program or to the asset running on the AS400. And then the response or the output, right, from the AS400 application will be translated back to an API response, right, to be given back to your mobile app, right? You're the user using the mobile app, or to another application that requires the function requires the data from the execution of the function of the application. All right. Okay, let me share the screen for the demo. Right, so you can see this is our IDE, right? This was mentioned by Marty as well, right? From the IDE, this is where we develop the API, the SDK and the API. There are two parts, right? So I'm going to show you how we can quickly develop an API to connect to the AS400 system, our demo system, all right? So I can just call this AS400 demo. So as I mentioned, there are two parts to the our solution. One's the SDK. Here, so here we actually specify what kind of connectivity to the AS400 system, right? Could be screen, could be directly to the legacy program. This is called RPC. Right? So I'm going to choose RPC. So apart from AS400, we do have out of the box connectivity to many other backend systems like mainframe and databases, right? And so on. So as you can see from the list here. So let me just choose RPC, right? Direct connectivity to let's say to an RPG program. Here I'm going to specify the host name for that AS400 system and the user access, right? So with this user access, we'll be able to directly access the resources on the AS400 as well as the ability to execute those programs, right? So if given the authority or the user access right, so this user must be given the appropriate authority to be able to access the resources as well as to execute the programs. So we click finish. So it will be generating that the particular project, this SDK project, to connect to the AS400 system. And here, right, from here, right, I want to let's say I decide to connect to an RPG program, right? So in order to do that, right, I must know what is the path, right? What is the path to that RPG program? So I can just do a fetching. This is also mentioned by Marty, right? I can fetch the metadata from that program, right? But I must know the path. So let me specify the path. So this is if I know the path to the program, I can just specify that directly, and then I'll be able to fetch the metadata concerning this program. This is a RPG program. So once I do that, right, the resource will be fetched directly from the AS400 system. It will be an RPG program and then with the corresponding metadata. So it's fetching the source right now, right? You will see eventually, right? It is a RPG program with the corresponding PCML file, right? So the PCML file actually is a XML description of the data structure or parameter used by the RPG program. So this is an RPG program on the right-hand side. You can see on the left-hand side are the parameters, right, used by that program in terms of the what's the input, what's the output. You can see, right, it is, yeah, you can see on the right-hand side, the parameters is also reflected on the left-hand side, which is the PCML file, the data structure, right? So what we're really interested is to pass this PCML file, not the program itself, but the data structure, the parameters used by the program in order to generate the SDK that allows us to connect to that program and execute the program. So let me see, let me just go to that program. This RPG program on the right-hand side, which is this one. I can just generate model, right? That means I'm going to generate the Java model. Just a minute. So I generate model, that means I'm going to generate a Java model or entities or the Java data structure representing the PCML data structure that I see on the left-hand side of the screen, right? So it will be a Java representation of the parameters used by the RPG program, so that I'll be able to access. I'll be able to pass on the parameters from the Java from our solution, which is in Java, to the RPG program and execute it later on. Now you can see, right? Yeah. So what what you can see here, right, is the Java representation of the parameters, right, of the metadata, and again, the source code is already generated. So later on, this program will be executed, right, to connect to that RPG program and execute it through our solution. Yeah, so this is done already, right? The Java entity or the SDK has been created already for this integration to the RPG program. The next step is to be able to create the API that will wrap around this SDK, right, as an API, so that we can expose the function, right, as a API. So this call is a API project, the corresponding Java package. You can see, right, we can also, as part of this API project, we can also create this API as a microservice, right? So we support Openshift, PCF, Docker, pure Docker, and so on, right? So with this so-called microservice generation in terms of the script, right, we'll be able to generate the Docker container very easily, right? The microservice container very easily for this API project. But for the purposes demo, I don't do that. I just generate it as a normal API. And also the template, right? So if there's a repeatable API that you want to generate based on certain parameters, based on certain entity and so on, you can always use a custom project template here. So that is always, you don't have to change a lot of things. The template will automatically generate those standard parameters, standard connectivity, standard way of generating the API based on the template. So next, right? So here we specify the SDK just now that we have generated, right? To wrap around to wrap around with this API, so that those backend functions can be exposed as an API to the outside world or to any other application. So that is generating right now. Right, the project has been generated. Now the next step is to create that API, right? That service based on the SDK, right? So this is a customer service, customer API. So we can just say, okay, this is the service name. Can give it any name. Let's say I say customer, and what is the input to this API? So the input can be just a customer ID, right? And the output, right? What will you get back in return once you specify the customer ID to this API? Could be the whole customer record, right? first name, last name, the credit information, the phone number, and so on and so forth. So I can just choose that whole record as the output for this API. So input is a customer ID. The output is the whole customer record containing multiple fields. All right. So create that API. Yeah, so the API has been created automatically, right? The source code also has been generated, right? There's no need to do any additional programming or changes to the source code unless you want customization. So this is a POS method, and this is the input output, right? Corresponding to what you get from the what is the original data structure on the RPG program side, right? So this one, the API will be used all the way to integrate to that RPG program later on. So this is done already, right? So we can just start the API, start this API application directly. So now it's starting up, right? If you build the Java application, and then we'll start that application. Okay, so we started already. Let me share my browser screen. Right, this is our Swagger browser screen, right, for us to test the API immediately, right? So, but you can be actually calling this API from your mobile app or for another application, or maybe from your API management gateway and so on and so forth, right? But for the purposes demo, just let me show you this demo from the where we can enter the data, right, to test this API. This is the OAuth 2 authentication, right? One of the security mechanisms that we support, apart from other, internet security for API that we can support. So once that is done, right, now I can try out this particular API. It's a customer API where we can specify the customer ID, right? And then we'll give the so-called the customer information regarding this customer based on the ID. Right, so this is a very technical screen. Of course, this one can be presented properly by a mobile app or by any other application and so on and so forth, right? So we can just try another one just to make sure that it's still working, right? Yeah. So that is the demo. It's a very quick demo, right? Of course, this demo is about direct integration to an RPG program, but it could be to a COBOL, could be to also indirectly through the database or through the user screens and so on and so forth. And also, as I mentioned earlier on, right, we have other types of not so common integration, like using TCP/IP socket, or maybe using data queues, right, which is native to the AS400 system or application. All right, that's the demo. Okay, hand it back to Tiffany.
Thank you, Michael, for the short demo that you're presenting to us. Hopefully, it will gives all the audience some view regarding the solution that we can offer to the customer and contribute for the customer to build their API. So we are moving to the question and answer session. Is there any question from all the participants? Just unmute your Zoom and just let me ask, just let me know, or you can put in the chat room. I have one question first from the participants. He asking about, can we create several services into one API project? question most for
yes,
Michael.
yes, sure. We can do that. You can create multiple endpoints, right, as part of the API project, and you can also include multiple SDK project as part of one API project. That means instead of just one program, right, one program from a backend system, you can include more than one program. Or the other way is that you can also integrate to more than one backend system, maybe one AS400, one mainframe, maybe another AS400 system. So all these are all will be, we're having its own individual SDK as a project, but then all this can be also be combined under one API, and we can do orchestration between these calls to the multiple backend system as a single API or as multiple API. Can we change?
And I guess I actually did show one slide that had a mainframe with IBM connected together, and those were going into one microservice with an API on it. So that's the basic idea. Whether or not you do it with multiple IBM or whether you do it whatever way you want.
Okay, there's another question about can we change the RPG or COBOL code in the SDK too? Okay, we're not in the business of changing the the legacy application, right? We are just going to just pass the metadata that is used to execute the RPG or COBOL program, right? So we are not RPG or COBOL source code maintenance tool. We're just our value is to be able to integrate to such legacy programs without any changes.
Yeah, I think that the question they also asked was how this change versions can be handled, and if you are changing the RPG or COBOL and you want to then regenerate, one of the advantages, particularly with the templates and thing, is you can just regenerate again, and the change versions then are handled like any Java code change versions would, if something happens to change. Many times nothing actually changes because unless you change the interface to the actual COBOL, it doesn't really affect us. But having said that, if you change the data type or you changed the actual function that you're calling into, the arguments to it, then and we have to regenerate. The good thing is we can just regenerate and we can reparse and then regenerate and have everything working, but you're going to have to test obviously the other end systems in case anything really happened. But I think that was the part of the crux of also that same question, those two questions together.
Okay, thank you, Marty and Michael. So the next question regarding the support array of JSON objects. Is there any maximum length of the output?
There's no maximum length to the output, right? All this will be restricted by the so-called, let's say it's a matter of presentation. Let's say those JSON object is likely to be presented on a mobile app, for example. So the mobile app must be able to restrict, right, the display and be able to have paging, right, to display the data in a complete screen, maybe one page at a time, that kind of thing. There's no there's no limitation to the length, right? So the only limitation in terms of presentation, how much are we going to process one at a time or maybe all together and so on and so forth.
And is it support for array of JSON object?
Yes, definitely we support that. Yes.
Yep.
And he asking for the statistic related to the TPS after the conversion itself. Maybe we can share after the webinar session for the data sheet of the statistic that we having from our experience. And the next regarding the possibility to handling bundling service program in AS400.
Bundling service program, maybe can elaborate a bit. This term is not very clear. bundling service.
I understand there are dedicated service bundles and things like that that sometimes come. I'd probably have to look at the specific ones. I mean, in general, we parse programs where we either have source code to it, like COBOL or something along those lines, or XML definitions, something where we can parse the information about it. If it's programs that just are sort of already there and executable, you don't have any type of source to it, then there are ways we can do it, but it takes, we'd have to have a discussion about the particular one you're dealing with and things like that.
Okay.
Yeah, let me add to Marty's point, right? So basically, if we don't have access to the source code, right, what we can do, as I showed just now, right, if you can get hold of the PCML of the RPG or COBOL program, for example, anything that can be used to describe the interface, to the program, right? Then we'll be able to integrate that program through the parsing of this metadata, right? What is the input parameters and what are the output parameters from this program? As long as that is available, right, then that's fine. We can still be able to integrate to that application or program at all the multiple entry points, right, to that application. So once we get hold of that, then we'll be able to integrate to that application, even though we have no access to the source code.
Okay, I think somebody clarified a little bit what they meant by TPS at another one. The OpenLegacy connector, is it smart enough so the call to the AS400 program or database is efficient? If the TPS is high, the transactional processing is too high. We make it very smart. One of the problems why things are so the transaction processing is so high in many cases is because you do the data conversion actually on the legacy side, on the IBM. We don't do that. We actually do it inside of the microservice as part of the call. So our actual call to it is just immediate, and the actual processing doesn't have to happen on the actual IBM machine. So that takes some of that off. The other thing is it's a direct connection without extra middleware and extra queues you have to go through, which takes a lot of extra code and calling. So in general, ours are very efficient, and the data processing is done off the machine itself, which is a problem a lot of other things do when they try to make it happen. So I think that would help answer some of the questions there, hopefully. If I didn't answer it, feel free to ask another one, but.
Okay, thank you, Marty and Michael. So for close our session today, I have received one more question from the participant regarding they're already using the ESB to help them to develop the API without any problem. So they are okay with the implementation of the USB itself. So why they should use OpenLegacy to do the same thing? Maybe just the positioning of the solution. Just give them the brief of what is the position of the solution.
Well, so it depends on what they're using the ESB for exactly. If they're just using it for queuing stuff, which in some cases they are, I don't know how they're actually getting access to their IBM machine. It varies a lot depending upon what type of system you use, but many times they put the API directly on the IBM machine, and then they have the ESB has to come out inside the actual cloud or somewhere along those lines. The problem with that is it's very brittle. If you ever make changes to anything on the machine itself, you always have the API always has to be rebuilt because it's part of the actual IBM. You get no abstraction from it. If you have multiple machines, you can't combine them and make one larger API. You wind up with tons of different APIs all across it. Now, if you want to use your ESB, though, close to your API as to do orchestration, particularly business logic orchestration up inside your system itself, I say that's great. We partner with companies like Boomi, which are the same type of thing, and we partner with other ones that do API builders. Like Axway and Apogee, they have API builders, and then we just provide the fast connection to the actual legacy system to allow you to then get it into the ESB and then do orchestration of the business logic itself on inside of the cloud or wherever you're doing it to build those microservices to work together and communicate. So some of our customers do use ESBs there. We just try to make the connection faster to the legacy system and automated. So we generate it for all different ones. So you can get into an API factory type of model for that.
Okay, Marty, thank you for the explanation. I think we have done our time for this webinar session. First of all, thank you for all attendees here for your participation for today. Hopefully, our sharing today give you some brief regarding the positioning of the solution itself. And we are very welcome if you need some clarification or question we need to share with you, or you will asking the small demo to solve some a concern from your organization. We are happy to having you during the discussion. So you can contact me through our emails, marketing@anabatic.com and also info@openlegacy.com. We will happy to answer all your question and concern. We are happy to having a further discussion with you and your team and also maybe from your management. Thank you for the time and participation, and hopefully we can meet with another webinar session. Thank you, Marty and Michael, for the sharing for today. Bye-bye.